In this lecture video, we're going to be talking about the PRESS statistic. Now, you'll recall from the section on residuals that one type of residual that we looked at was called the PRESS residual. The PRESS residual is the difference between the observed value of the response and what we might call a leave one out predictor of the response. Now, what do we mean by that? Well, for the ith observation, what we do is we leave that observation out, and we use the other n-1 observations to develop the predictive model. And then we predict the ith observation using that model. And because the model was not developed using the ith observation, the predictor for that ith observation is going to be independent of the ith observation itself. And so the ith observation is not going to be able to have an influence on that predictor. And so the difference between the ith observation and the leave one out predictor of that observation is called the PRESS residual. Now, the PRESS statistic is the sum of the squared PRESS residuals. And we talked about how you can think about the PRESS residual in the way we just described, where you fit n separate models. You fit a separate model for each observation where we leave that observation out, develop a model, and then predict that observation using that leave one out predictor. And you do that for all n observations. And once you have those leave one out predictors, you calculate the PRESS residuals, and then you could calculate the PRESS statistic by squaring those PRESS residuals and then adding them up. But we also talked about how you don't actually need to go through that process, although it is useful to think of it from that standpoint, at least from a conceptual level. But it turns out that the PRESS residuals can be calculated not only as the difference between the observed value and the leave one out prediction, but also as the raw residual divided by 1 minus the ith diagonal element in the H matrix. And so we only need to fit one model, calculate the raw residuals, and then determine the diagonal elements in that H matrix and calculate the PRESS residuals in this way, and then square them and then sum up the squared values, and that gives us the PRESS residual. So that's a more computationally efficient way, certainly, to calculate the PRESS residuals and the corresponding PRESS statistic, because you only have to fit one model. Now, the way that we interpret a PRESS statistic is that larger values of the PRESS statistic are bad from the standpoint of how well that model is going to predict future observations. A smaller value of the PRESS statistic is desired. And so if we have for a particular model, a relatively small value of a PRESS statistic, then we can be fairly confident that the model is going to do a good job of predicting future observations. And this can be used, for example, when we have 2 or more candidate models to choose from that we're wanting to use for predictive purposes. We can calculate the PRESS statistic and use the PRESS statistic as a means for deciding which model to go with. So we could choose the model, for example, that has the smallest PRESS statistic and have a fair amount of confidence that it's going to do the best job in terms of predicting future observations. Now, just as there is an R-squared value for a given fitted regression model, R-squared again is the coefficient of determination. There is an R-squared value based on the PRESS statistic. We call this the R-squared for prediction, and it's given by 1 minus the value of the PRESS statistic divided by the total sum of squares. So in this note, in the book, in the slides, they denote that by SS subscripted with a T. In other books, you'll see that abbreviated as TSS. All right, but however you denote it, the denominator here is the total sum of squares in the response. And so again, the R squared for prediction is 1 minus the value of the PRESS statistic over the total sum of squares. And the way that we interpret this is that we expect the model to explain about R squared for prediction times 100% of the variability in predicting a new observation. And as we said before, the PRESS statistic is useful for comparing models, especially when we're wanting to use the models for prediction. So what I want to do next is to look at a couple SAS programs to see how we can calculate the PRESS statistic. We're going to use PROC IML, the interactive matrix language. We'll also use PROC Reg, and we'll see in PROC Reg how to get the PRESS statistic and how to get the R squared for prediction as well. But let's take a look at PROC IML. And we're going to look at this in the context of example 4.6. So we're continuing to look at the delivery time data. This IML procedure or program implements the calculations for the following types of residuals and related quantities. And so we've looked at some of this in a previous lecture video, all right, calculating the raw residuals, the standardized residuals, the internally studentized residuals, the externally studentized residuals, the PRESS residuals, and then once we have those PRESS residuals, we can calculate the overall PRESS statistic. And then what we're adding to the program in this, for this purposes of this video, is the R squared for prediction. So we showed how to calculate these other quantities in our previous lecture video, and we're going to add to this by calculating the R squared for prediction. And so let's take a look, and we'll scroll down here. And we've seen much of this program before. And so let me see here. Let me just get rid of that, and we'll fix this up when I post that to the website. Okay, so let's scroll on down. And again, we've seen most of this, listing the data, calculating the parameter estimates, calculating or constructing the fitted model. We also need to calculate the hat matrix so that we can get the values from, let me see here, to calculate the denominator in this formula, this really economical formula for the PRESS residuals. All right, and so let's go down here. And so now we're calculating the model residuals. And so we calculate the raw residuals, and then we calculate the standardized residuals. Scrolling down a little bit further, we have the internally studentized residuals, the externally studentized residuals, and then here we calculate the PRESS residuals. Now, the formula in the textbook and in the slides here shows calculating the PRESS residuals from the raw residuals on a residual by residual basis. In other words, calculating each of these separately. And as you might recall, that in a previous lecture video, we showed calculations for doing that kind of thing, where we, for example, construct a loop where I goes from 1 up to n. And we're doing this in the context of the internally studentized residuals. So we were calculating these one at a time. But we also saw how we could do the same, a similar or really equivalent way of doing this using matrix calculations. And that's what we're doing here with the PRESS residuals. So we're using matrix calculations to calculate the vector of PRESS residuals all in one fell swoop. And so that's what we're doing here. And this is equivalent to implementing the formula or performing the calculations that we saw on the slide. And then once we have the vector of PRESS residuals, all right, then we can calculate the PRESS statistic very conveniently as the inner product of that vector of PRESS residuals. So the transpose of the PRESS residuals times that vector of PRESS residuals. And so that's calculating the sum of the squared values of those PRESS residuals. And then we print those out. Okay, then I calculate the total sum of squares. And then once we have the total sum of squares, we can calculate the R squared for prediction. It's equal to 1 minus the ratio of the PRESS statistic to the total sum of squares. And so then that will give us the R squared for prediction. Okay, so let's run this and see what we get. Okay, so at the very top, we have the data set, and then we calculate the parameter estimates. We have the vector here of parameter estimates. Here we have the hat matrix, and the diagonal entries in the hat matrix are the values that we need to calculate the denominator in calculating the PRESS residuals. All right. And so then, as we saw before, this is just the various kinds of residuals that we can calculate. All right, so what we're interested in here is down here at the very bottom. So the value of the PRESS statistic is 459.0393 approximately. And then the R squared for prediction is 0.92064. And so the way that we would interpret this value, this R squared for prediction, is that we would expect the model to explain about 92.64, let's say 92.064% of the variability in new observations when we're trying to predict those new observations. So that is how we can calculate the PRESS statistic and the R squared for prediction using PROC IML. Next, let's look at PROC Reg and see how we can do the same thing. And so again, we're going to be looking at example 4.6. And then this SAS program shows how to calculate or how to obtain the following types of residuals from PROC Reg. And so we have the raw residuals, but the internally and externally studentized residuals, the PRESS residuals, and the overall PRESS statistic. We're also going to show how to calculate the R squared for prediction. So let me go ahead and I'm going to copy that, put it over here in this program. There we go. So I'll show you how to do that. Okay, so we have the data, the delivery time data, and we're going to invoke PROC Reg to fit the model, and we're going to obtain the residuals using PROC Reg. Now, again, we're going to use ODS select to select the tables to output, and we are going to include the residual statistics, but we're also going to create an output data set that contains the raw residuals, the internally studentized residuals, the externally studentized residuals, as well as the PRESS residuals. Okay, and the name of that output data set we're going to call residuals. All right, and we're going to use that data set in calculating the R squared for prediction. Now, another line that I've added that we haven't seen before is the ODS output statement. And what this is going to do is it's going to create output data sets containing the ANOVA table from the analysis, as well as the residual statistics from the model. And so when we're using these various procedures in SAS, it's a good idea to remember that when we're outside of PROC IML, so when we're doing the normal kinds of SAS processing that we use with the various PROCs, whether it would be PROC means, PROC reg, and so forth, those always operate on data sets. And so if we want to try to manipulate the values, calculate values based on the output from the various PROCs, we need to keep in mind that we need to do this in the context of data sets. And so with these two output statements, we are calculating or constructing a data set. We're outputting a data set that contains the various kinds of residuals. And we're going to be focusing on using the PRESS residuals. But we're also calculating output data sets containing, again, the ANOVA table for the analysis, as well as the residual statistics. All right. And once we have done that, okay, then I'm going to create a listing of the residuals data set just so that we can see what's in there. All right. And then what I'm going to do is I'm going to open up that residuals data set so that I can calculate a derived variable. And what I'm going to do is calculate the square of that PRESS statistic. And I'm going to call the squared value of the PRESS statistic PRESS_2. Then we'll go ahead and print out that data set once again so that we can see what we've augmented that data set with. Okay, and so then we've got some further processing to do. But let me just also say that once we have calculated the squared values of the PRESS statistic, then we're going to use PROC means to calculate the sum of those squared PRESS values, and that's one way of obtaining the PRESS statistic. So let's run this and let's see what we get. So we're going to run that first part of the program that we just discussed. Okay, so we have the ANOVA table for the regression analysis. We have the model information, model fit information. We have the parameter estimates. And then we have the various kinds of residuals that come directly out of PROC Reg when we ask for that table of residuals. And so we have the raw residuals, we have the internally studentized residuals, and that's really about it. But we also asked for the table containing the residual statistics. Actually, this is where we asked for that. We output a variety of types of residuals, including the PRESS residuals. And now we're going to print those out. And so let's see what happens when we do that. And this is the listing that we get. This is the data set that we get. So we have the raw residuals. We have the internally studentized residuals. We have the externally studentized residuals. And then we also have the PRESS residuals right here. And so we see that we can get those PRESS residuals from PROC Reg. All right, then what we did is we performed a data step. We opened up that residuals data set for processing and we calculated this derived variable. Again, this is the squared value of the PRESS residuals. And then we're going to print that data set out. And so let's take a look. Okay, and so here we have the same table as before with the squared values of the PRESS residuals appended on the right-hand side of that table, or augmented would be a better word. So the table has been augmented with the squared values of the PRESS residuals. And so the square of negative 5.5980 is 31.337. The square of 1.2336 would be 1.522, and so forth. And so these are the squared values of the PRESS residuals. And then we used PROC means to calculate the sum of the squared PRESS residuals. And so this is the value that we get, 459.0393147. And that's exactly what we got when we used PROC IML. So that's one way to get the PRESS statistic. But if we go back up here from the default output from SAS or from PROC Reg, you'll see that we already had, it automatically prints out that PRESS statistic when we ask for when we specify the correct option in the PROC Reg. So we see we hit 459.03931, which is the same value we got down here. And the way that we get that table there that includes the PRESS statistic is when we select the residual statistics to be displayed. And so that's how we get that directly. But we also see how we could calculate it if we wanted to using this means. Now, one thing that we don't get in this table is the R squared for prediction, although it would be very easy to calculate that by hand, because the R squared for prediction is just 1 minus the PRESS statistic. So 1 minus 459.03931 over the total sum of squares, all right, which is 5784.54260. And so once we have that, we could use a hand calculator to do that, to get the R squared for prediction. But we can also do some programming in SAS to get that automatically. And so here what we're going to do is we're going to use some data stepping to calculate the R squared for prediction. And so you'll recall that up here in PROC Reg, we asked not only to create an output data set containing the residuals, but we also asked for output data sets to be constructed containing the ANOVA table and also the residual statistics. Now, we're going to be processing those different data sets to get the rows and columns in those data sets that we want. Essentially, what we need to do, we need to get a data set that contains not only the PRESS statistic, but the total sum of squares on the same line in a data set. So we're eventually, or essentially here, just going to do some data step processing where we end up with a data set with one row and the values that we need on that one row. And once we've done that, then we can calculate the R squared for prediction. So we first open up the ANOVA data set for processing. And what I'm going to do is use the if statement here to select the one row in that data set that corresponds to the corrected total. And what it's going to be doing, let me go back up here to the ANOVA table and the output, it's going to be selecting this row in the analysis of variance table. And then what we're going to do is we're going to select the column, okay, that corresponds to the column containing the total sum of squares. And that column in that data set is labeled, or the variable name is SS, sum of squares. And we're going to derive a new variable that has that same value, but I'm going to call it TSS to be consistent with the notation that we're using. And we're going to tell the data step to keep that one variable. And so what that does is it takes that data set that contains the ANOVA table, and we get, once we run through this data set, we have a data set that has one row and one variable. That one variable is the total sum of squares. Then we're going to open up the residual statistics data set for processing, and we're going to select the one row that contains the predicted residual sum of squares, or PRESS. And if we go back up to the output, this is the data set that we're going to be opening up, the data set containing this information, and we're going to be selecting out the one row in that data set at the bottom there. So we're going to select out that one row that I've highlighted, and then we're going to select the column containing the value 459.03931. All right, and so this is how we do it. So we select out that one row, and we're going to create a variable called PRESS and set it equal to the variable containing that value, which is n value 1. And then we'll tell the data step to keep that one variable. And so we end up, again, with a data set containing one row and the variable containing the PRESS statistic. Then we're going to create a data set. I'm just going to call it Scratchpad. And we're going to merge those two data sets. Now, those two data sets each have one row, so it's just going to create a data set with one row and those two values on that same row. And so then once I have that, I'm in a position where in that data step, I can calculate the R squared for prediction. All right, because it has both the PRESS statistic and the total sum of squares on the same row. And so I can do this calculation. And so once I do that, then I can just print out using PROC print the value R squared prediction from that Scratchpad data set. All right, and so let's see how this works. Okay, so here we have the R-squared for prediction, 0.92064. And you'll recall this is the same value that we got when we calculated it using PROC IML. So certainly if we're using PROC Reg, and if we needed the R-squared for prediction, we could calculate it. We calculate it by hand. We have the values in the output that we could use for that purpose. But if we know how to program SAS, we can get that value without having to go through and calculating it by hand. All right, so that's what I wanted to show you in this lecture video. We'll continue with the next topic in the next lecture video.